People often ask, why are you using openSUSE instead of Fedora? The truth is, Fedora has grown up with Fedora 43 and beyond. You get Btrfs by default, faster hardware support, and modern kernels. Add to that the new Leap 16 switching to SE Linux by default. Suddenly, Fedora and openSUSE are not that far apart. But openSUSE still holds a key advantage: Snapper plus Btrfs snapshots out of the box, allowing safer rollbacks after any update. Today, I will put Fedora to the test. Can I make Fedora behave like openSUSE in this area? Can I switch back to Fedora with confidence? Let's find out and build something that no tutorial leaves half finished. I'm going to use Fedora KDE Plasma desktop. Also, as you can see, I'm using already Fedora 43 KDE Plasma. By the end of this video, you will see the same here for Snapper. Starting with the Fedora 43, every Fedora spin will use the new Anaconda Web UI, web-based installer by default, giving a consistent and modern setup experience across all desktops. I have to say, this installer is so good that it made me wonder, why didn't openSUSE release Leap 16 with something like this? And then it clicked. Now I understand why openSUSE switched to Agama, their new web installer. They are clearly taking inspiration from Fedora. Funny, isn't it? Anyway, I'm using a VM here to demonstrate and simulate a real-life scenario. Once you put to Fedora 43 KDE Plasma, you need to start the installation by double-click on this icon on the desktop. On GNOME, you will be greeted with the installation window. Now the installer is started. I will try to fast forward to reach the main step for here, which is the partitioning or the disk layout. So again, the target here is to install Fedora with Snapper and Btrfs. If you have a previous installed OS on your system, you will see this window: share disk with other operating system, use entire disk, mount point assignment. If you have no previous operating system on your disk, you will see only use entire disk. And this one is the one that we are going to use in all cases. You don't click on next here, but you see these three dots on the top right. We click on launch storage editor. This window, the storage editor, lets you resize, delete, and create partitions. It can set up LVM and much more. All changes made in the storage editor take effect immediately, so be careful about that. And I hope you backed up all your important data before you start the installation. So as you can see, the disk is already laid out from a previous installation to simulate a real-life scenario. During installation, Fedora already defaults to Btrfs for the root file system, and the new installer finally allows you to create subvolumes manually, just like openSUSE. This layout is proven in enterprise systems. It separates system data from user data and makes rollbacks clean and predictable. Notice here the first partition, EFI system partition. If I go and try to format it, you can see here in the type EFI system partition. When you see this, means your system is UEFI system. If you cannot see EFI and you see BIOS legacy partition, means your system is legacy BIOS. If your system uses legacy BIOS, no UEFI, it is still possible to install Fedora with Btrfs subvolumes, just like on a UEFI system. So the installer will not always refuse if you have no EFI partition. You just must ensure the correct boot partition is created for the mode you are using, UEFI or legacy BIOS. So let's move on with the installation. We will format the first partition, EFI. If I go here and choose EFI system, mount point with the /boot/EFI, confirm, format. And now I have a home partition. I don't need to format it. All I need to do is to come here and edit mount point. I write the mount point, in my case here /home, save. Now my home partition is mounted. It will not be formatted unless if I come here to the partition and I choose format. As you can see, I have a swap from a previous installation. Again, we are simulating a real life scenario. And yes, Fedora is using ZRAM, but still no harm to have a swap partition. Now the important part, the root partition. Format, I will name it Fedora. Don't mount it, leave it as it is. And then I confirm formatting. Now, when you start creating subvolumes on root, you start from here, top level, not from here. Here you only see format or delete. So we start creating subvolumes from the top level. We click here, create subvolume. The first one is root, mount point /root. And Fedora installer does not allow /root, the home folder for root user, to be its own subvolume. It must stay inside /root, the main root file system. To work around this, we will create a temporary subvolume. Create subvolume. The subvolume name will be root_home. And let me add something here. Btrfs subvolume names cannot include hyphens, use underscores only. And a temporary mount point root_home. When the installation finish, we will change that to be /root. Let's create a subvolume for USR local. Create subvolume. We will name it local. USR local. Create subvolume for SRV. Create and opt and /pt. Create. Let's create one for var. Create subvolume var/var. And for people who might using KVM and using the root for that, let's create lib_virt var lib. Someone might ask why we are creating all these subvolumes. Let Snapper capture only system changes, not user data or volatile logs. Once you have created all subvolumes and assigned the correct mount points, let's hit on return to installation. If no issue at all, you should see this. Means everything is okay and you can continue with the installation. Next, and let's enter a username for our system, password, and you might need to enable root account. Next, continue Fedora installation. After rebooting into your fresh system, we will configure Snapper, turning Fedora into a snapshot ready system, just like openSUSE. Hit install. The system is successfully installed. Let's reboot and move to the next step. Now we booted to newly installed Fedora. Before we dive into configuring Snapper, let's do a quick setup to ensure your system is ready for snapshots and boot recovery. Let me first change the host name using the command hostname control hostname and the hostname. I log out and log in again. Now the hostname, change it. Enable the grub menu so you can boot into snapshots later. Run the command grub-to-edit-env space list and then run the command grub-to-edit-env space unset menu auto hide. Let's run the list again. This ensures the grub menu appears instead of skipping automatically. Critical for rollback access. Second thing, exclude the snapshot directory from file indexing for performance. We will edit /etc/updatedb.conf and we will add /.snapshots to the variable inside the file I will show you now. This prevents tools like locate from scanning the large snapshot directory constantly. Go ahead and open the file, and here at the end we will add /.snapshots. Be careful about the spellings. Save the file and exit. Next, install Snapper and the DNF Actions plugin. Run the command dnf install snapper lib dnf5-plugin-actions btrfs assistant. Snapper handles btrfs snapshots plus rollback. Lib dnf5-plugin-actions lets DNF run pre-post snapshot commands. Btrfs assistant is a GUI management tool to make managing a btrfs file system easier. Maybe you expected me to say make sure your system is updated first. Actually, I delayed that step on purpose. I want to test Snapper later. In Fedora, DNF5 does not natively trigger Snapper snapshots, but thanks to libdnf5-plugin-actions package that we installed earlier, we can easily hook Snapper into every package transaction, just like openSUSE's automatic rollback system. If you want to learn more about that, you can go to the official manual of DNF5 and check the actions plugin section. Here it shows you the action format in this, and thankfully it gives us an example at the end of this page. When you go down, you will see here an example actions file. The lines we need from this example, these lines here, and you can see the description: emulate DNF4 Snapper plugin. It uses the Snapper command line program. If you just copied these lines and you go and create a file in this path, snapper.actions /etc/dnf/libdnf5-plugins/actions.d, and as you noticed, the extension under actions.d directory is .actions. You will get the bare minimum hook Snapper into DNF. Following the official manuals, I created this file which contains all the needed configuration in order to make Fedora behave like openSUSE, and I added some explanation and comment for each section to understand what is going on in this file. When you check the end of this file, here the last 3 lines copied from the official manual and tweaked by me. So make sure to read everything here, like for the first line, description, just the process name, creates a snapshot description and save it to the temp.snapper_description variable. So when you run snapper ls, you know this snapshot was happen or triggered by what. Don't forget to check the description below for the download link to get a copy of this file. So now I will copy these lines. I go and I create a new file in this path and paste it here. Make sure to exit and write. Again, in brief, how it works. Before each transaction, DNF records the command you ran. For example, DNF install and takes a pre-snapshot. After the transaction, it takes a post-snapshot and links the two together. The snapshot descriptions now include the exact DNF command, making it easy to know what triggered each change. Every time you run DNF install or DNF upgrade, Fedora will automatically take a pre-snapshot and a post-snapshot, giving you full system rollback safety, just like openSUSE, Tumbleweed, and Leap 16. So don't forget to check the description and download your copy of this file. Now, you still remember the subvolume we created during the installation for /root home folder? Let's use it now. First, unmount root_home. Then we will use this path to backup /root home. Consider this as mimicking a real-life scenario. You have files under /root. Let's back it up first to root_home. So now we backed up /root home folder to /root_home, and make sure that this one is unmounted first, /root_home. Then change directory to the parent /root, and safely we can clear anything under /root. We already took a backup for it, so now /root has nothing. Then go to etc/fs tab and you go to the line that contain _root_home, and all you need to do is to delete _home. Exit and save the file. Don't forget to run system control daemon reload after you finish editing fs tab file. Now we can do mount -a, we can change directory, and if we run df-h, now /root has its own mount. Let's get our files back from the folder. Now the folder root_home, let's say I don't want it anymore. So if you want to delete it, make sure to end it with /. Don't delete it like that. If I did that, the subvolume root_home itself will be deleted. So make sure to add / at the end. Let's move to the next step. Now it is time to set up Snapper so it can manage your root file system. In our case, we have two options in order to do that. Using command line, as you can see, you can run this command to create a configuration for Snapper, or using the Btrfs assistant GUI application. I'm going to use the GUI app because because it is more easier, more clear, and it is easy to follow up with me. The GUI is clear enough and easy to understand. Here, like file system, it will be listing the Btrfs partitions on your system. The first one will be the root always. Subvolumes, here the subvolumes on your system. Snapper, after we create the Snapper configuration, here you can start making snapshots. Snapper settings tab is what we are looking for to create a Snapper configuration. First, we click on new and you can choose the path from here for this configuration. In our case, /root, and the name is root. After that, you click on save. Now we have a Snapper configuration created for root. And down here, systemd unit settings. We have 3 services: Snapper timeline, Snapper cleanup, Snapper boot. The Snapper timeline service is responsible about creating a snapshots on periodic time. Default configuration, every 1 hour there is a snapshot will be created for your /root. Here, Snapper cleanup, we need to enable this because this one is responsible about running Snapper cleanup service. And we have Snapper boot service. This one, if we enable it, every time you have a successful boot to your system, there is a snapshot to your root file system. You can enable it if you want a snapshot every time you have a successful boot to your system. Here, enable timeline snapshots. This one is related to the service, so we don't need to have it enabled. So make sure to click on save again here after you change anything and apply systemd changes. Now all in place, and here you can do Btrfs maintenance. Let's look at Snapper tab. Now we can see select config root. If you have more configuration, Snapper configuration on your system, you will see it here. And we can create a snapshot to our system, subvolumes, and here as an overview. Before we leave the GUI, we need to click here on enable Btrfs quotas, and I will show you now the command related to this to enable Btrfs quotas, and there is another command you need to run after enabling Btrfs quotas. So if you enable it from the GUI, the second step is to run the second command. So this command is the same if you ran enable Btrfs quota from the GUI. From command line, Btrfs quota enable /root. And here the second command after you enable quota, Btrfs quota from GUI or command line, in all cases this is the second command you need to run. So let's hit enter. Now we can check our Snapper configuration by running snapper ls. The next step is to make sure that /.snapshots is mounted and has an entry in /etc/fs tab. If you run Btrfs subvolume list /root, we see here .snapshots subvolume created, and this subvolume is the subvolume from root. So go ahead and open /etc/fs tab. We are looking for the line that contains the root mount point. If you are using VI like me, double Y and then P to copy the line and paste it beneath it. All we need to do is to go here. The mount point will be snapshots, and for subvolume name snapshots. Save and exit. Make sure to run system control daemon reload after you edit /etc/fs tab. Now we can run mount-a, and when we check df, we can see /snapshots is mounted. This step is very important to enable grub-btrfs. So let's enable grub aware of Btrfs snapshots. Now install grub-btrfs, which allows grub to automatically detect and list your Btrfs snapshots so you can boot into previous system states. Now we need to enable this repository to be able to install grub-btrfs. Let's hit enter. Now let's install the package by running dnf install grub-btrfs. Once the package installed, we need to enable this service. system control enable -- now grub-btrfs.path. Your Fedora system now mirrors openSUSE's snapshot architecture with all subvolumes manually created at install, /.snapshots properly mounted for grub integration, Btrfs quotas enabled, and Snapper ready for automatic rollbacks and boot time restores. Now let's test the configuration we did so far on our system to make sure that Snapper is working and behave as we intended to. As you can see, we have a snapshot entry created because of the package we installed earlier, grub-btrfs. Now I will run DNF upgrade to check if we will see the important equally yes or no. So as you can see, user data here, description, DNF install, cleanup number. By the way, if you go default, copying and paste the 3 lines from DNF documentation, any snapshots will be created. It has no cleanup algorithm. So in that case, you need manually to administrate your snapshots. Now we have clean number algorithm assigned number in place. So when you run the command snapper cleanup number, the snapshots will be cleaned following the configuration for the Btrfs partition. So now let's run DNF upgrade. I will pause and I will be back when the installation finish. Now the upgrade finished. Let's check Snapper by running snapper ls, and here we can see DNF upgrade important equal yes, and before we install the normal package and the importancy was no. So I can say perfect. We made Fedora behave like openSUSE in this area, Snapper plus Btrfs. To make this video complete, there are some things I like to do on my system after Fedora installation. First, I go to etc dnf.conf and I come here in main and I add these 3 lines. Save and exit. Next, I like to go to RPM Fusion website to install RPM Fusion non-free and free packages for Fedora 43 for multimedia packages and codecs. So copy link, DNF install, first link for free, second one for non-free, and install. Then let's make DNF upgrade. Next, for FFmpeg, Fedora comes with the free one. If you want to swap for the non-free ones, so you run the command dnf swap, allow erasing, and the package you want to swap, then the package you want to swap with, and we hit enter, we press yes. You are into gaming, Fedora comes with RPM Fusion for Steam, if you would like to install Steam on your system. So you need to make sure that Steam repository enabled on Fedora by running this command dnf config manager, and you set the option for enable to be 1. So when running dnf repo list again, RPM Fusion Steam is enabled. If your system has an NVIDIA GPU card, all you need to install is akmod-NVIDIA. If you have AMD GPU card, you need to install AMD GPU firmware, AMD SMI, and ROCm. So here I give you a Fedora behave like openSUSE in this area, Snapper plus Btrfs, making sure that you have the chance to roll back to a working state of your system. One last thing, let's check our system if we are able to boot from one of these snapshots. So let's reboot. Now we see the grub menu and we can see an entry here, Fedora Linux snapshots. We can see all the snapshots on our system, and simply you can choose any snapshot and boot from it. Here we did the upgrade. I would like to go before the upgrade. If I hit enter and next line, and now our system is booting from this snapshot before the upgrade. Let's log in. We can check our system. It is before the upgrade because the new kernel on Fedora in the moment of recording this video is 6.17.5. We can do reboot again to check our system. Now let's boot, and here you have a Fedora system behaves like openSUSE. Yes, openSUSE truly set the standard. Snapper and Btrfs integration are not just add-ons there. They are part of the system's DNA, supported and tested from day one. Everything works out of the box and you get rollback confidence without ever touching the terminal. On Fedora, we had to take the long road, planning, configuring, and wiring everything together manually. But in the end, we achieved the same power: full system rollback, automatic snapshots, and a safety net that just works. And that's the beauty of Linux. You can always build what you need, learn along the way, and make the system your own. Fedora has come a long way. Its new installer, its polished KDE experience, and its commitment to open technologies show how much it's matured. So here is my friendly wish to the Fedora team. Consider integrating Snapper plus Btrfs natively, just like openSUSE does. The foundation is already there. It just needs to be connected for users by default. As for me, this marks the start of a new chapter, exploring Fedora again, seeing how far it's come and what it can offer next. With our rollback safety net in place, there is nothing to worry about, only more to discover. If you believe every Linux distro deserves built-in rollback protection, share your thoughts below. Tag Fedora. Let's start the conversation. Stay positive, stay Linux, and as always, thanks for watching.